Hello and welcome to Learn with Islam. I'm Sheikh Azhar Elahi, and after decades of implementing AI solutions globally, I can tell you this: space-based data is becoming as critical as internet data for industries ranging from agriculture to defense. Today, we are diving deep into how AI-powered satellite image analysis is changing the game for terrain classification and real-time risk detection. We are not just talking theory. I will show you the exact technical approaches, tools, and pipelines used in real projects worldwide. So why terrain classification matters? Satellite terrain classification is not just for maps. It impacts agriculture, for crop health monitoring, soil mapping, also disaster management, flood risk zones, landslide detection, for urban planning, land use, construction feasibility, defense and security, for border monitoring, movement detection, and for environmental monitoring, deforestation, glacier retreat, etc. For example, detecting early land erosion near riverbanks can save millions in flood prevention. So, what are the core AI techniques which are used to implement it? Firstly, we use multi-band image processing. Satellites like Sentinel-2, Landsat-8 capture images in multiple bands: RGB, near-infrared, shortwave infrared. Different bands reveal unique terrain features: vegetation, water, urban areas, bare soil. For example, NDVI, Normalized Difference Vegetation Index, helps distinguish vegetation from barren land. Then we use semantic segmentation. We use deep learning models to classify each pixel in an image into categories like forest, water, urban, snow, etc. Unit and Deep Lab V3 Plus are popular architectures for this task. Unlike classification, segmentation gives pixel-precise boundaries for terrain types. We also need to implement temporal change detection. Compare multi-day satellite images to detect change over time. For example, new construction, forest fires, glacial melting. It requires image registration plus change detection models. So how we implement all this in real world? If we talk about the pipeline, first of all, we need to acquire the data. Pull satellite data from Google Earth Engine, GEE, or Copernicus Open Access Hub. Choose the right satellite based on resolution and revisit time. Then we need to do some pre-processing: atmospheric correction, remove haze, normalize lighting, also cloud masking, remove cloudy pixels using Sentinel-2 QA bands. Then we need to do image alignment for multi-temporal analysis. After that, feature engineering is the next process, in which we generate spectral indices, NDVI, NDWI, NDBI, etc. Then extract texture features for rocky terrain. Then normalize pixel values across different bands. Once it will be done, we need to move towards modeling with semantic segmentation. We train a unit model using multi-band input, for example, 10 to 13 channels instead of just RGB. Also, loss functions like dice loss plus cross entropy for better accuracy in imbalanced terrain types. Then we need to do data augmentation, rotation, scaling, and band mixing, etc. Post-processing is also very important part over here. We need to apply morphological filters to remove classification noise. Also merge small fragmented areas into larger terrain zones. And finally, the visualization and the deployment. We usually serve results in ArcGIS or Google Earth Engine maps for decision makers, and also build dashboards for real-time risk alerts. So let's discuss about some tools and frameworks which we can use in order to implement it. First of all, Google Earth Engine, which is massive geospatial data sets and pre-processing power. Then UNIT, PyTorch, TensorFlow, pixel-level terrain classification. And also ArcGIS, QGIS is quite important for GIS analysis and visualization. Rastrio, GDAL, is also handy for GeoTIFF data handling. And then Sentinel Hub for API-based satellite imagery streaming. Now talk about real-world implementation. For UNEP and Google used Earth Engine to monitor Amazon deforestation in near real time. Pakistan's Indus River flooding monitoring project uses Sentinel-1 radar data plus AI models to map flood-affected areas within 24 hours after heavy rains. Also, India's ISRO integrates unit-based segmentation into national land using mapping. So there are certain best practices which we need to take care while implementing these solutions. We need to use multi-sensor data, combine optical Sentinel-2 plus radar, Sentinel-1 for cloudy regions. We need to account for seasonal changes, avoid false change detection caused by vegetation cycles. Also, we need to balance accuracy and latency. Real-time alerts require lightweight models, not just high accuracy heavy networks. Also, human-in-the-loop verification, critical for disaster and defense applications. From monitoring climate change to optimizing agriculture and mitigating disaster impact, AI-powered satellite image analysis is transforming how we see our planet. And the beauty is, with tools like Google Earth Engine and ArcGIS, this capability is no longer limited to space agencies. Startups, NGOs, and local governments can implement it today. If you want me to build a live demo for terrain classification using multiband Sentinel-2 imagery and a unit model, drop a comment below. Don't forget to like, share, and subscribe to Learn with Izhar, where AI meets the real world. Thank you and have a nice time.